Sometimes it might be appropriate to assume the population variances are equal. Again, you have to be really careful about making that assumption. If you don't know, just assume that they're not equal. But occasionally, you will be able to do this. And like I said, do your homework. Most of the time it's going to say assume that they're pooled or not pooled. This does, if we have equal variance, if we're pooling our data, we have a slightly different formula for our t-statistics. So you can see the numerator is the same. The denominator gets a little more exciting. So you can see that. I'm not going to read the whole thing to you. Degrees of freedom also changes. Okay, so instead of the smaller of n minus 1 or n minus 2, it's n1 plus n2 minus 2. So the advantage to pooling the data is you get a higher degree of freedom, which gives you a little bit more accurate test statistics. All right, so we have a home improvement warehouse, and they claim that people who are doing their own projects can save time by attending workshops. And they say that people who attend the tiling workshops take less time on average to complete the projects than those who do not. So people who attend, we're going to call that population 1, and people who do not attend, we're going to call those population 2. So they randomly select 10 people who attended the workshops. So that's N1. And surveyed them about their tiling project. They spent a mean of 14.1 hours. That's X bar 1. And a standard deviation of 2.3. That's S1. Another 10 people, there's our N2. They did not attend the workshops, and they did a tiling project too. They spent a mean of 15 hours. There's X bar 2. And standard deviation of 2.4. So here's S2. So we want to test the claim that these workshops are helping people save time at the 0.01 level of significance. Okay, we don't know the variances, so we're going to have to use a t-test, but we are assuming them to be equal. Okay, so that's pooled. Okay, but we don't know. The variances are unknown, standard deviation unknown, so this means we're doing a t-test. Okay, so again, we'll do it by hand, then we'll do it on the TI, and then we'll be done. So, our null and alternative hypothesis. So we want to say the people who did the workshop took less time on average than people who did not, or U1 minus mu2 is less than 0. So then the null is the opposite of that. Okay. We are doing a 2-sample t-test at alpha equals 0.01, and we are pooled this time. Okay, and that was told to us in the problem. All right, so if we're doing this by hand, we need to calculate t. So we have x bar 1 minus x bar 2, so 14.1 minus 15. And then mu1 minus mu2, that's just from the hypothesis, 0. And then the exciting denominator, n1 minus 1 times s squared plus n2 minus 1, minus sign there, minus 2, times s2 squared over n1 plus n2 minus 2, and then we've got another square root, 1 over n1 plus 1 over n2. Okay. When I'm putting this into my calculator, I usually start with the denominator, like I start with this square root thing on the left side, and then I multiply it by the square root thing, and then I do the numerator divided by that answer, if that helps. So, push all the buttons in our calculator, and t turns out to be negative 0.856. All right, so we want to compare this. From our hypothesis test, we are running a left tail test. So we are looking for t 0.01. And whatever's on the table, we're going to have to make it negative because we're on the left side, which is no big deal. Degrees of freedom. Degrees of freedom are n1 plus n2 minus 2. So 10 plus 10 minus 2 is 18. So you're going to look on your yellow sheet. Degrees of freedom is 18. Look for 0.01, and we get negative 2.552. Now, our t statistic falls right about here. That is not in the rejection region, so we are going to fail to reject. H sub O. So what this means is at the 0.01 level of significance, I'm going to do a lot of abbreviating here. The data does not support that the workshops reduce time. Workshops reduce time. Now, obviously that's not the best description. Does not support that attending the workshops reduces time spent on your tiling project. So we should be a little more specific, but I'm kind of running short on space. Okay, you can also do this in the TI. You're going to go to stats, stat, tests, two sample t-tests, and you're going to go to stats. You're going to fill in all of the data that we just talked about. X bar 1 is 14.1, S1 is 2.3, N1 is 10, so on and so forth. Make sure you put that mu1 is less than mu2, and for pooled, you're going to type yes this time. When you do that, you'll hit calculate, and we are concerned about the p-value. So once you get that all in, p turns out to be 0.2016. We compare that with alpha, which is 0.01. Obviously, our p-value is not smaller than alpha, so this is a fail to reject, which is what we got by hand as well.